Okay, today we're finally going to start 2.2, more graphs and displays. We're going to start with graphing quantitative data sets, stem and leaf plot. Now, pretty much every one of you has done a stem and leaf plot before. As a matter of fact, pretty much everything in this section is fly through because it's all things that you've done before. So when you're doing a stem and leaf plot, each number is separated into a stem and a leaf. Separation depends on the spread of the data. Sometimes the leftmost number may be the stem, and the rightmost number will be the leaf. Other times, the two leftmost numbers will make up the stem. Okay, data set lists the number of text messages sent last week by the cell phone users on one floor of a dorm. Display the data in the stem and leaf and describe any patterns. So first, when we look at the key, you have to have a key in the stem and leaf, so that I know that two numbers are going to be to the left of the line, potentially. Obviously, if it's a number in the 70s, then it's only going to be one number to the left of the line and one number to the right of the line. Okay, and then it shows that that's equal to 155. So basically now you just go through and fill your data in. Now, again, as always, it'd be nice if they put the data in order from least to greatest. And so if that's something that you want to do, you're more than welcome to do that. But I'm going to have to look for my 70s numbers. And I see I have one number in the 70s. It's going to be a 78. And so all I write here is 8. That's it. The rest of the numbers are 3-digit numbers, so I know I don't have to put anything next to 8 or 9. I can move over to the 10 somethings. Now here, I just kind of space them out because you have to put them in order from the least to the greatest. So like 101 would go here. First number I come across in this category is 109. So I'm going to put a 9 out here. And I see I have a 108. A 105. And so that's where putting your numbers in order would actually come in to help. Because as you can tell, we're going to end up with like 105s and 109s. 105s are lowest. We have 3 109. So now it looks foolish with it all the way over there. So I can drag it in, but you can't. So it sucks for you. Good for me. That's it for the 100s. I forgot to cross out this 105. Okay, next we move on to the 11s. So I can go through and I can look for a 111. So no 111 there or there. Lowest I have so far is 114. There's a 113. There's a bunch of 112s. So I have 1, 2, 3, 112s, and a 113. Okay. So that's going to be 2, 2, 2, and a 3. All right. What about 114? There's one of those. So we have 114, 115. See, I have a 116. And so you can go through it like this too. And 117, 118. There's 118. 2 118s. 117. 3 118s. 119. 1, 2, 3, 120s. Let's see, a 121. There's one of those. There's two of those. So two ones. Look at 122, 123. There's a 123. There's two 122s. Two, two, three. 124s. There's a 124. Oh crap, I missed a 122. I don't know if I just didn't cross it out. Let me go back to 122 before I do 124s. I'm already done. Might as well put it down. There's two fours. 122. There's one, two, there's three 122s. You can kind of squeeze it in there if you mess up. Probably gonna mess up at least one more time. 125s. I didn't see any of those. I'm gonna start actually crossing these out a little better too. See if you cross them out better, then it doesn't distract your attention from it. But if you make a mistake, you're screwed. Okay, let's check the 126s. 1, 2, 3, 4, 5. 127s. Don't see any of those. 128s. Don't see any of those. 129s. There's one, two. Now we're on the 130. There's one. No 131 either. 132. There's one. There's 133. So we have one 132 and two 133s. 2, 3, 3. 134. There's one right there. 4. 140. I don't know why I said 140. 135. None of those. 136. None of those. I see two 139s. 99. Now we can move up to 140. One of those. See a 142. There's a 144, two 145s. 4, 5, 5. No sixes. There's 147, 148. So 7 and 8. And now we have 155 and 159 for our last ones. Alright, so it's tedious work, but it's real easy. Just set up your key and make sure you know how many numbers you're going to put to the left based on the spread of the data. Now, you can also break this up. So example 2 is a variation of a stem and leaf plot. It says more detail may reveal more about the data than before. This time we'll split it, each group of 10 into 2. 0 to 4 leaves will be listed in a different stem than 5 to 9 leaves. Now this is the same data as before. right? So I'm actually going to, instead of having my data listed out here, I'm going to look back at my other stem and leaf plot, because it's going to help me a lot more than going through that data all over again. It also would help if it wasn't freezing up. There we go. Copy. Paste it in. But it didn't copy everything. You know, if I was in class right now and it was not responding like this, I'd probably just stop the lesson and give up for the day. Good thing I'm at home. Let's try it again. Let's group it all first and copy. Yeah, that's better. All right. So when we look at the data, it's 78. So that's going to go with the second 7. Then anything 5 or above goes in the second one. So 5, 8, 9, 9, 9. I don't know if you guys can even see this on the smart board. Let me see if I can. Then for my 1-1s, it's going to be cut off at 4s. So it's going to cut off here. So I'm going to have 3 2s, a 3 and a 4. Two, 2, 2, 3, 4. And 6, 7, 3 8s and 3 9s. Then our 2s getting cut off here. So it's 2 1s, 3 2s, a 3 and 2 4s. 2 1s, 3 2s, a 3 and 2 4s. Then 5 6s and 2 9s. So 6 6 6 6 6 9 9. 13 cutoff is at 4, so 0 2 2 3s and a 4. 0 2 2 3s and a 4. The other 13 is going to be 9 9. 14 0 2 4 5 5. So 0 2 4. Then 5 5. I think it was 8 9. 7 8. Close. And then lastly, 5 and 9. Okay, so you see how it makes our data look less crowded and jumbled. We can still see that the majority of the data is falling in the middle here, which is kind of the point of a stem and leaf. It gives you the ability to see what is happening with the data where the majority of it falls. All right, constructing a dot plot. This is essentially the same thing, except you're just going to put an X if it falls within that number or within that category. So our first number is 155. Put an X. 159 is closest to 160. Put an X. 144 closest to 145. 129 goes to 130. 105 stays where it's at. 145 stays where it's at. 126 is there. 116 goes to 115. 130 stays at 130. 114 goes to 115. 122, sorry, goes there. Next one's 112. 112. Those are both going to stay at 110. 142 stays at 140. 126 goes to 125. Again, a lot of tedious work. That's all this part is. 120 goes to 110. But on the bright side, pretty easy chapter test so far. Speaking of chapter tests, I'm missing some. Better make sure you get those to me, especially some of you seniors. 118 goes up to there. 110, 110, 120, 140, 140, 120 again, 78, 133, 126, 123, 145, 121, 134, 125, 120, 130, 133, there, 124, there, 129 goes at 130, 112, 10, 125 again, 148, and 147. Okay, that's what your dot plot looks like. Not too bad, we're just stacking them on top of each other. Again, it lets us see where the data falls the most. You can see that the 120 to 125 category was your highest number of text or whatever it was. Pie chart. This is really just a circle that's divided into sectors that represent categories. Area of each sector is proportional to the frequency of each category. Now, because you're not able to draw perfect circles, I'm sure, because who is? And you're probably not going to have a protractor. It makes it a little difficult to draw the pie chart. So what I would actually have you do is just figure out what the table is that goes with the pie chart. So first, we have to add up all these numbers. So we're going to do 942 plus 1716 plus 731 plus 164. That gives us a total of 2553. Okay? So if it's 2553, then now we have to figure out basically what type of degree it is, which would just be associates, bachelor's, master's, doctoral. So we're going to do in our chart type of degree. First type is associates, then bachelor's, then master's, then doctoral. Frequency is 942, 1716, 731, and 164. Relative frequency, you now take that 942 and divide it by your total. So 942 divided by 2553. And that gives you about 37% for your relative frequency. Then bachelor's, 1716 divided by 2553. It's going to give you about 67%. 167. And master's, should be about 29%. And lastly, doctorates or doctoral, 164 divided by 2553. And it's going to give you 0.06. Okay. Now you take that relative frequency, multiply it by 360. 0.37 times 360. It's going to give you an angle measurement of about 133 degrees. 0.67 times 360 would be about 241.2 degrees, so 241 degrees. 0.29 times 360 gives you 104 degrees. These numbers don't make any sense. You can't have over 360 degrees. Alright. I think I messed up when I added them up or something. Yeah, I was missing a 1. So all these numbers are wrong. My bad. So when we add up our total, it's 942 plus 1716. I left the 1 off. Plus 731 plus 164. I only did that to show you guys that you should check your answers and make sure that they make sense in context with the question. I was really just showing off why you have to do that. I'm lying, obviously. All right, 0.27. I can hear people complaining about writing in pen already. This one's 0.48. This one's 0.21. And this one's 0.05. Now we multiply those by 360. 0.27 times 360, which gives 97.2, or just 97. 0.48 times 360, it's 173. And 76. And lastly, 18. So now whenever you put these in your pie chart, you use a protractor. Start at your center of your circle. You can start anywhere as far as your degrees go. But if that's your true zero, then you would go 173 degrees from there. I will make this true zero and go 173 degrees this way. It's going to come over here like that. So you're going to flow back to your true zero, just like that. And so that would be the people with the bachelor's degrees. Now from there you would go 97 degrees. You can see why making a pie chart is a hassle. So you would line up with that and then go 97 degrees. I really don't know how to make this protractor work on this thing. Would you go 97 degrees? Be like there. Draw a dot. Draw a line from your home to there. Then from there you would go 76 degrees. I'll spin this thing. There we go. So from here you go out 76 degrees, which would be like right in here, I think, like that. And that would leave you with your last little bit, which would be the 18 degrees. And so your pie chart would look something like that. Again, I'm not going to have you draw that. I'm simply just showing you what it would be. All I would have you do is the table so that you don't have to worry about dealing with the protractor, working your way around like that. All right, constructing a Pareto chart. A Pareto is a bar graph that goes from highest bar to the smallest, and your bars don't touch. That's literally it. So retail industry loses money through inventory shrinkage every year. The following are the main causes of shrinkage: administrator error, employee theft, shoplifting. I know some of you guys. Unknown, and vendor fraud. So employee theft is the number one reason, which kind of surprised me. Those are actual numbers. But employee theft is the number one reason for having inventory shrinkage. And so if we create a Pareto chart, we just go from the highest problem or the biggest problem to the lowest. Let's say that's 2 billion, 4 billion, 6 billion, 8 billion, 10 billion, 12, 14, 16. Okay, and then you just label the bottom as whatever, like whatever this would be. So let's start with ET, employee theft. That's $15.1 billion. So it goes up to there. Shoplifting is next, and it's 12.3. Go a little above 12. Then is administrator error, which is 4.2. Then is vendor fraud, which is 1.7. Then lastly is unknown, which is 1.1 billion. To which I say, how do you not know where $1.1 billion worth of stuff went? Like $20 is missing from my wallet. I know what happened to it. But so shoplifting, administrator error, that's your boss doing the wrong thing. Vendor fraud, that's when they say they brought 2 boxes of chicken nuggets, but they only brought 1. They took the other box home. And then the last one was unknown. It's pretty easy. Graphing paired data sets, I'm not even going to make you draw this out. It's a scatter plot. You've been doing this your entire life. Boom. You get dots that go all over the place. And then you try to set a trend from it. That's really it. Then the last one is a time series. It's the same thing, except you're measuring it in time, right? So if it's composed of quantitative entries taken at regular intervals, instead of worrying about the year, we would do subscribers up one side and average bill down the other. And subscribers. And that's it. Alright? So not bad. We're going to do lots of problems on it again. I might give you 3 days to do it because your homework was so long last time. Or I might knock some problems off. But we'll start those tomorrow.